When people think about hackers, folks intruding into systems, they often get the cinematic version. You could look at Johnny Mnemonic or a bunch of others. One of the more notorious versions of this is Hugh Jackman in Swordfish. And if you were to look at someone who was really intruding in it, it wouldn't look much like Hackers, the movie. It wouldn't look much more like Swordfish. It wouldn't look like playing a video game, right? Actually, you'd probably look like someone on a telephone trying to socially engineer access to a password or something like that. But if they were on a system, it wouldn't look very much like this at all, right? It's not not necessarily a time thing. It's not finding puzzle pieces, right? Ironically, what it would most likely look like is something that is a likewise representation that you wouldn't expect to find realistic, which is in something like The Matrix. This got some attention when it came out. This is Matrix Reloaded. When Trinity sits down to shut down the power grid, she doesn't kind of go through these video things. She picks up a shell and she gets access to the shell and gets access to root. And then from there, she manages to figure out which system shut down the grid. And this is actually pretty, there's nothing realistic about this. Obviously, you're not going to be able to sit down at a console somewhere and quickly shut down the entire city. That's just not how it would work, right? But at least that part, the getting access to the grid, that is, or rather getting access to the shell, that is pretty commonly the way people who work on computers work. It means not having to use the mouse. It means being able to directly kind of interact with the operating system without a lot of cruft between you and what's happening. In fact, I think you could argue that, before people called themselves data scientists, there were lots of people doing the things that data scientists do. Gathering data, cleaning that data, wrangling the data, comparing it and changing it in various ways. A lot of that happened at the shell. Now, I will admit that I don't do a lot of work in the shell these days, but you could be well served by being able to do a lot of the stuff that we can do in Python or in R or in other tools. We could do a lot of that directly from the shell. When I'm talking about the shell like this, what do I mean? If you've used Windows before at some point, you may have opened up and run a program, or you may have opened up and gone to something like the command prompt, right? This is the Windows shell. And you'll see it tells me that I'm at /users Alex, and I can type dir and find out what I have in this particular directory and that sort of thing. So we do have a shell, a Windows shell. It's not very powerful. It's a little bit confusing, and it doesn't have a lot of the pieces that we need. If you're running, I should have a picture of this, but you can figure it out. If you're running OS X, you can just go into the Finder and find your terminal and start up your terminal. It looks a little bit like this, but it is actually a much closer to what we're going to handle today, the bash shell. I'll note that there's one, you can add some of these commands in. There's one command that we'll talk about today that you can't get, that isn't available by default in the shell for OS X systems. But most of this stuff you can find right there in the shell. We're going to use instead the bash shell, as I noted, which is the shell that is one of the shells that is available for a Linux or Unix type system. It's called the Bourne Again shell. It's very, very popular. If you're running Linux, you most likely have a bash shell already there, and you just open it up. That's going to be your terminal shell. Strangely, Windows had this this period in which they were experimenting with a kind of a Linux subsystem, and it turns out there is a way to I've closed it out, but there is a way that you can install the bash shell kind of natively on your Windows machine, and you can actually go to the Windows store, the Microsoft Store, and search for Ubuntu, and you'll find this. Ubuntu on Windows allows you to use Ubuntu terminal and run Ubuntu command line utilities, including bash, SSH, and git, and apt, and others. So this is a little bit weird, right? Because we've talked about kind of Windows is different from the others because it's not a Unix-like system. But it turns out that there's other ways to do this. We can install a VirtualBox and then install a full copy of Ubuntu kind of on a virtual machine, but you can actually run it natively on Windows with a few small shifts. And it tells you here that you need to kind of find the features in the command you need to kind of flip some switches in the settings of Windows to do this. I'll send a link that will kind of walk you through how to do that. But once you've flipped those switches and enabled the ability to do Linux virtualization, you can actually just install this and launch it as a Unix shell, a Linux shell. Either Ubuntu, they actually have other SUSE and others, but Ubuntu is the one we'll be using directly on your Windows machine. So let's go ahead and do that. I'll bring that over real quick. So this is what it looks like when you open it up. This is the bash shell. You'll see that it says what my username is and what machine I'm on. The reason for this is you can actually secure a shell. You can do the SSH command and log into other machines from this machine. So it helps to be able to look at the shell and say, okay, what context am I in right now? What system am I actually interacting with? And right now I know this is the user I am logged in as, and this is the machine I'm logged into. My machine is named Alice. And so I can look here and kind of see where I am. Let's do an ls command. Ls is to list the files in this directory. It's not very exciting because there's nothing here. Let's ask where I am. So pwd. You might mistakenly, especially new people, will assume PWE has something to do with passwords. It doesn't. PWE is for print working directory, and it's kind of a way of saying, hey, where am I? Right? So this is my where am I command, and it tells me that I'm at /home/halloway. This is actually my home directory. Okay, so directories are, just like on any computing system today, kind of arranged in a hierarchy. At the top you have just the slash. This says CentOS, but it's for pretty much any Linux type system will have these kinds of directories at the top level. And then you'll see home is there. And then in this particular system, I have another directory inside home, which is the Halloway directory, which is my home directory. But if I let other users touch my machine, I might have multiple home directories there, right, for various users. As it is, I only have one user on this machine, so I have only one kind of home directory here. I'll back out here. If you don't install Bash on your own machine, if you're not using it on your laptop or your desktop computer, you might use SSH to kind of go to the High Performance Computing Center, the Agave cluster. And then if you look at it, you'll find that there's probably hundreds or more directories under home, because each of the users is going to have their own home in that space. All right. So how can I kind of traverse this directory tree structure? I can kind of go up and down through this structure to kind of move around. To go up, I can go CD. I can do a couple of things. I can give either an absolute or a relative command, CD command. So I could do CD/, if I found the slash, and that would take me up to the root home directory. Okay, so if I do that, and then I do pwd, it's going to tell me I'm right up at the top here. See, it says I'm at the very top of the tree structure. And if I do a quick ls here, there's all of those things that we just looked at, all of those directories and a few more that we just looked at sitting up here at the top. This doesn't give me a lot of details about what those are. If I wanted some details, I could do ls, not ks. Well, let's do ks. ks -l. And it's going to say there is no KS. So it gives me an error. Again, don't worry too much about errors. You can make some mistakes when you're at the shell. It's a very powerful tool. So we'll talk about, especially when you're erasing things, it's very easy to make mistakes. But generally speaking, if you make a mistake, it's just going to say, that didn't work. So what we were looking for there was actually LSL. Commands at the shell have you can have dash something, right, to do various flags. Sometimes those will take a variable. In this case, -l just means I want the long version of the listing of the directory. And so this gives me kind of the long version here of everything that's in here. I won't go into the details of what it's telling me, but I'll just touch on a couple of things. Some of these, in this case, because of the way the shell works, the colors tell me a little bit. So it tells me, for example, that the green ones are an actual file, whereas the blue ones are directories. I could have guessed that a couple of other ways, but this colors it to make it easier for me. In these cases, don't worry too much about it. They're aliases. In other words, they're going to take me to a different directory. This is like shortcuts on a Windows or a Apple machine. Actually, for OS X, you call them aliases as well. So this kind of takes me to a different folder than it says it's taking me to. No big deal there. This tells me when this file or directory was last modified. So for example, this init was modified on September 10th at 3 in the morning, right? So this kind of tells me when each of these things was last modified. This tells me how big the file is. Since these are directories, they're quite small, but actual files might be a little bit bigger in bytes. This tells me who owns it. This tells me the permissions. So remember that Linux systems and Unix systems were from the very beginning set up to be multi-user systems. That's unlike sort of Windows and OS X, which were born as being, well, OS X is a little tricky because as I said before, it builds out of some of the operating system tools that are found in Linux systems. But generally speaking, both of those were meant for personal computers that only had one user. Now, all modern operating systems, most modern operating systems at least, maybe not on mobile phones, but most desktop and laptop operating systems these days have some kind of multi-user function, right? You can log out and let your roommate or kids or whatever log into their own account and not have access to other things. But that was really important from the very outset for Unix machines, since multiple people would be using the same machine, often at the same time. And so these actually talk a little bit about who can do what with each of these files. And I don't think for us, for now, it's super important to talk about permissions. Basically, this says who can read, write, or execute the individual, the owner, the group, what they can do with these files. For what we're doing here, we probably won't run into that as an issue. At some point, you may need to dig into that by looking kind of at questions of changing permissions on these things. So this gives us an idea of what's there. Just because I've forgotten, you'll see that it's not uncommon to have to do this a bit. I'll print my working directory and remember that I'm up here at the root. So if I wanted to go back home, there's a couple of ways I could do it. One way I could do it is I could go cd home, and remember that this is not quite home yet. And then I could go cd Halliday. So I've dropped down one to home and then next down to Halliday. And now if I do pwd, I'm in /home/Halliday, right? Let's go back to where we were up here. I could also, now remember I'm up at the very top of the tree again. I could also go cd, I could give an absolute. I could say cd home /Halliday. So that gets me right down in one go, right? It's like giving someone the actual, instead of saying go down the street, make a left, make a right, it's actually saying go right to this address, which is /home/Halliday. I'm mentioning this in part because although we do this in the shell, we also do this when we're dealing with specifying the names of files in Python, for example. We might do an absolute, or we might do a relative reference to a file name. A quick note, let's go back up to the very top again, and again, I'm up here at the very top. The other thing we can do is we can make this a little bigger maybe so you can see. The other thing we can do is from the very top, we can just do cd by itself, and this is like tapping your heels together and saying, there's no place like home. It takes you back to your default home space. This seems silly, but honestly, when you're tooling around a very large file system, it's easy to forget who you are and where your home is, and this gets you back to your home really quickly. You won't be allowed to do a lot of changes, even on this system. You won't be able to do a lot of changes outside of your home directory necessarily without kind of logging in as a super user, as root. But as a regular user, you probably won't be able to change a whole lot in those upper spaces, but you can look and see where everything is, and that can be helpful. All right, now this is I still don't have anything here. It's kind of boring. Let's create a directory. I'm going to do make dir, and we'll call it data. All right, now if I do an ls, I've got that data. If I do lsl, I've got, it tells me that it's a directory. And I can actually go into that directory by typing cd data. And I obviously don't have anything in here because I just created it. So what if we wanted to put something in here? Well, we don't have any data handy. We could use something called, not Nana, but Nano, which is a built-in, I think it has Nano. It's a built-in text editor that you can do with the command line. There's lots of those. There's well, again, there's lots of arguments that go back sort of decades at this point around Emacs versus Vim versus all kinds of questions of what's the best editor you can use. And frankly, the best editor I can use right now doesn't have anything to do with the command line. But most shells at this point will have access to either Nano or its predecessor Pico. Shout out to the Huskies, since my PhD's from University of Washington. Those were written at the University of Washington. So there's editors that you can get access to. So we could edit a document and write it, but we probably wouldn't do that. Instead, what we might do is we might get some data from the web, right? Because that's something pretty common. So there are at least 3 ways we could do that. At least 3 ways. At least 4 or 5 ways, actually, just offhandedly. I want to kind of take a quick moment to note that if you forget how any of these work, you can type man. It depends on what system you are, either man or help, but I'll show you that in a second. So man gives you the kind of manual for this particular command. And ls isn't that exciting. LSA is nice. It kind of shows you some of the hidden files. This kind of gives you some of the options you have. I'm hitting space here to kind of space through the directory, but there's lots of, sorry about that. There's lots of possibilities here of how I could use ls. I'm not sure if I'm going to be able to get this as help. So that's the other option, is you can kind of do the help file, which gives you a different set of things from the manual. It depends on the system you're on. Sometimes help will be useful. Sometimes man will be useful. Sometimes you'll hit man and nothing will show up. So you need to be able to do either one of those. So if you have a question about a particular command, you can always just kind of ask, what's the manual for it? So what are the ways we could get some things from the web? We could use FTP, which is File Transfer Protocol, but there's really 3 main ways we might do it. We might use something called wget, and wget has all kinds of options for it. I'm not going to use wget mainly because I don't think it is by default available on OS X. You could always install it, but I think this is one of those cases where it just doesn't have to be part of the shell in OS X. So we're instead going to use its cousin curl. Both of these were developed in the 1990s to kind of get data from the web. I'll mention offhandedly the one I'm not going to talk about is secure copy, which basically copies a file from a system other than the one you're on into your system, or the other way around. So it's actually very useful, but you can't really, it's a little tricky for using for the web, right? And we're going to use it for the web. What are the differences between wget and curl besides a whole different set of commands around them? Both can be used for like filling out forms and getting data, for logging into systems on the web, all those kinds of things. The main difference is wget actually can go and crawl sections of the web. So you can ask it to not just wget one page for you. As far as I know, curl won't do this directly, but you can ask it for it to kind of archive an entire website. Especially in the early 1990s or mid 1990s when these were developed, that was really useful, because if you wanted a local copy of a website from the web, if you're doing kind of social research and you want to have a copy of the website, you could actually go in, drop down to the shell, and wget the entire website, and then you'd have a copy of it. Now, it didn't always work perfectly, but it worked pretty well for archiving data from the web. But as I said, we're going to use curl. I'm going to do a quick manual for the curl, and it will tell us a little bit about what it's for. It's for transferring data from a server using all of these various protocols. Gopher, good luck with that. But the one we'll be using is HTTP or HTTPS, right? But you'll look, POP3 is a way of transferring files over mail, so it can do lots of kinds of different things, right? And it mentions that it can do FTP support, HTTP posts, so that you can fill out forms, all kinds of tricky things that you can do. And there's tons and tons of examples of how to use curl online. But we're just going to do something simple. I'm going to get the data from, my homepage. So there it goes, and it grabs it all down. Now, it's not displaying it as a web page because this doesn't do displays of anything graphically. That's not really, well, it's not what it's intended for. You can actually do some graphical stuff within a shell, but right now we don't want to be dealing with that. So instead, it's giving me Wow, a lot of stuff and the entirety of it. So it just went and grabbed that. Let's do a quick ls now. Uh-oh. So it grabbed it, but it's not here. So by default, when I do curl, it just kind of dumps it to the screen. There's some other ways we can do this, but this is a good time to talk about how we could redirect this stuff into a file. So let's do that again. So I'll do that, but I'm going to do a little more than sign, and then I'm going to say my site. Because it's HTML, I'll go call it my site HTML. Okay, so I'm going to run that, and it speed upload. It doesn't really tell us anything because it went so quickly, but it kind of tells us what it's working on. But instead of printing to the screen what's going on, in this case, if I do a quick ls, you'll see I have a new thing there called mysite.html. How do I look at that thing? There's lots of things I could do, but I'm going to do cat mysite.html. Cat is actually short for concatenation. It's not really to look at things necessarily, but it will kind of spit this out to the screen the way I wanted it to. So there it is, sitting in my data, mysite.html. That really went quickly. I could instead, for example, say less mysite. Oops. Right. And what this does is you'll see that it does the first page of it. This is the very start of the file, and it goes to here. And if I can kind of go through it this way little by little until I get to the end if I want to, instead of doing it all at once, right? And I can hit Q there and I'll bounce right back out. But that will let me page through it. I generally won't do that because I'm not going to read through it like that. It's not a document, right? But what I can do is I can do head mysite.html, and that's a little more common, where we just kind of get the first few lines so we can see what it is that we've got. Or we might do tail, right? And that gives us the last few lines. You can see that there's no new line here, so it's actually giving me the prompt over there instead of where it belongs over here on the left. I can do that. It'll clear this up if I needed to clear the terminal for some reason. So let's see what we've covered so far. We've covered ls for list the files in your directory, pwd for print the working directory, cd, which changes your directory. Remember, cd ... goes upwards, or you can name the directory you're changing into. We've done makedir, mkdir, to make a new directory. We've done man for manual. We've done a curl. We've done the little moving things into redirecting the output into a file. We've done cat, we've done less, we haven't done echo, but we've done head and tail. So we've kind of covered the ways we can look at files and deal with them. There's some other little ones in here. In fact, a lot of the things that there's something called, let's take a look and see what happens if we do, I don't know if this is on there, we'll find out. Sequence 5, that's the same as range 5. It gives us a sequence of 5 numbers. Why might you want to do that? Well, it probably doesn't surprise you that I can actually do for loops on here. There's no manual entry, but I can actually script this so that I can do for loops using those sequences and do things over and over again, for example. So far I've kind of moved things in, but I haven't done piping. So let's do that real quick. I'm going to do, let's do a quick, what do we call that? mysite.html. So what does that do? Well, we don't know, but we can do man for WC. And it tells us that gives us the new line, the word, and the byte counts for a file, so we can find out how big a file is. On the one that I just did, let's see if I did L for lines. So if we look here, you can see that I did WC-L for lines for mysite.html. It tells me that there's 703 lines in mysite.html. I could do WCL mysite.html and put it in. So now I've got this called wordCount.txt, and what that means is I can actually have the output there if I needed it. I don't really need that file right now, so I'm going to rm word count. I don't want to type the whole thing, so I'm going to say were star.txt. Star replaces anything in there with what it could be, and so you have to be careful with it, right? I'm using, especially when I'm using RM, because that could remove things I don't want to remove. As I said, mostly you can't mess too much up. It's a little more dangerous because you have more power at the prompt than you would in other places. You can't mess too much up. You can still, it's not like Python. You can make some errors that will change the directory structure or change stuff that's on your machine in various ways. But RM is one of the exceptions. There is no trash can, no basket it's not going to ask you. Well, it might ask you. You might do like this. And that will ask you to ask it to ask you. But generally, it's when you remove, boom, it's deleted. So be careful with RM. There's actually a deadly command that can remove everything, every file on your system. And if you hit enter after that, kind of you're in trouble, right? You're wiping it. Just starts wiping out every file it can find if you give it a very hungry indicator for doing that. So right now I'm just going to do that. And in this case, that -I says, I'm being a little careful. Do I really want to remove this one that it found? And I can hit yes and it will do it. But generally I don't use -I because I'm pretty sure I know what it is that I'm removing. The advantage here is when I'm doing a star there to kind of say a wildcard, to say anything that starts with war and ends with .txt, then I want to make sure that it's actually matching the things it's matching. The other one I could have done, which is... I'll do a cat instead. I can do anything that's my site. I could do it like that, right? And it will do my site dot. I'm going to hit the up key here. Oh, I'm going to hit enter and then I'm going to hit the up key. So what this says is up key gets me the last thing I typed. So what this says is my site dot star is anything that starts with that. But I can also do my site dot. Maybe I only want ones that have 4 things afterwards, and that will get that one. So the question marks only match a single letter instead of matching any string. So that gets me a way of kind of accessing various things, right? Okay, so we've done remove. We've done wildcards. I think we've covered most of the things we wanted to cover. The one exception we haven't touched on yet is piping. So we've done this to kind of redirect output into something, but I can also do something like curl. Again, I'll do my website. Oops, I will try to find the slash. So I'll do my site, but instead of redirecting the output into a file, I'm actually going to pipe. Now, you probably do have to look to see where your pipe is on your system. It's not T, but for me it's here. It's that symbol there, the kind of line up and down. You probably don't use it that often in your everyday life unless you like making boxes in text or something. But this is called the pipe symbol. What it says is it says take the output from the command on the left and put it into the command on the right. So I can do a word count, for example. And then if I wanted to, I could actually put that into something, but I'm just going to have it printed to the screen for now. And so what it does is it takes the output from this command and pipes it back into this command, which is kind of hard to see here, but it's the 703 right here, because this is actually producing an output as well. But this pipes that output into this and then does a word count for me. If you're starting to see, you could build some pretty powerful stuff here just out of commands in Bash. We'll stop here for now and talk about some ones that are particularly useful for figuring out what's going on in a file or manipulating that in various ways in the next section. But I just want to kind of give you the feel for each of these commands are useful in and of themselves for like manipulating data. There's ways of, I should talk about renaming. So we've got this here. Let's say I want to rename this. I'm not going to rename it. I'm going to mv move it from mysite.html to mine.html. So now if I do an ls, it's actually moved that to a file. I could move it up, right? I could move mine.html. Now again, I can do an absolute or a relative URL here. If I start with a slash, it's going to be an absolute URL, but I'm actually going to do a relative URL and say move up by 1 and call it mine.html. So let's see what happens there. Now if I list here, it's not here anymore, but I can go up 1 level and it's moved it up here. Now I can move it back down, move mine.html to data. Again, there's no slash in front, so it's going to be a relative. Data slash mine.html. Now it's not here anymore, but if I go back down into data, it's here. I can also CP for copy, mine.html to also mine.html. And now I've got both of those there. And you can, if I do a quick search here, you'll see they're the same size, for example. So adding those two, I didn't have them on my list, but adding to my list, copy and move. One of the powerful things here you could do is if you had a whole bunch of files that were misnamed, for example, and you need to name a whole bunch of them, you could very easily do something that pipes the names in and kind of iterates through a whole set of them by using just the star to kind of change names on files or to delete particular kinds of files. So there's a lot of power you can do just with single commands, but you can also assemble these commands into kind of mini programs, scripts, shell scripts that you can run that, especially if you do some kind of data processing that happens regularly, where it's kind of collecting things regularly from the web, for example, and then doing something with it, you could do all of that within the shell itself. There's also some more powerful tools that we'll talk about in the next video. Thanks.